Hi, everybody. Good afternoon or morning, depending on where you're joining us from. Thank you so much for being here with us. We're really grateful that you're here. And I'd like to thank my colleague Jazz for being here as well. He's going to rock your world with an introduction to Terraform, is what I'm told. So thank you for coming again, and we will start in just a moment. Just want to go over just a couple of housekeeping things. Our upcoming webinars are at our website at webagesolutions.com/webinars. And if you're looking for any past recordings, you can find them on our YouTube channel. But today we're here to talk about Terraform, and just to let you know a little bit about WebAge Solutions. We've been in business for over 20 years. My name is Anne, by the way, and I've worked for Accelerate WebAge now for about 20 years as well. And we're very happy to bring you industry-leading technologies, upskilling, AWS and cloud, Microsoft technologies, mobile, JavaScript, and many other things. But today we'll talk about Terraform. And if you look on our site at webagesolutions.com/courses/Terraform training, you'll see all the classes that we have. And Jazz teaches many of them. In fact, he's been focusing on infrastructure as code and Terraform now almost exclusively. He wrote two of our very popular courses, Terraform for AWS and Terraform for Azure. So he's developed them, and he's taught both of them. And actually, just right after the little intro, I'll go ahead and put those URLs in the chat so you'll have them if you want to check out the class, because the only thing that's better than an hour with Jazz is a 3-day course with Jazz, and they're both 3 days. And he's been all over the world to teach and consult, and he does teach our Terraform classes, and I think you're going to find him very engaging. He really is just as nice behind the scenes as he is in front of the class. So, all right, I'll stop gushing, and I'm going to go ahead and let me just go ahead and I'll kill my camera and make you the presenter, Jazz. There we go.
All right, thank you so much, Anne. Let me share my screen. I believe, there we go. Screen 3, show my screen. All right, and can you verify you see my screen? It says infrastructure as code on it.
Yes, perfect. I can
awesome.
Now. Wonderful.
Okay.
Great.
Okay,
right,
perfect.
Great.
Perfect. Thank you so much. Thanks for this awesome intro. I really appreciate it.
You're the best.
So, well, welcome everyone. My name is Jazz, Jazzwell, and I am right now in Madison, Wisconsin, and it's about to turn really cold and wintry in just a couple of days. And so I'm speaking from my home, and one of the things that we're going to take a look at in this webinar is just what Terraform is, and especially like how infrastructure as code works and the theme behind it. So my plan for today is to kind of like just show you give you a sense of what IaC is, and how Terraform can change the paradigm for infrastructure, right? So we'll just start with you know, the standard Wikipedia definition of infrastructure as code, and I want to talk about this, and we'll take apart some of the items in here. So infrastructure as code is the process of managing and provisioning computer data centers, and this is Wikipedia talking, right, through machine readable definition files. So this is a big one, which is the files themselves are machine readable, i.e. you have written code that your computer can read, right? And this is different from doing physical hardware configuration, right? Like imagine like you actually buying a set of servers, boxes, and setting them up in a data center, right? Not doing that, but actually writing code. But also not doing interactive configuration tools. And so what I mean by that is typically if you're using AWS or Azure or any of the cloud providers, a lot of times one of the ways you can actually create infrastructure is you can go into the console, right? So you could go into something like the AWS console. This is the AWS console. And in here, I could say, launch an instance and create an EC2 virtual machine in one of the regions, right? So let me go into Oregon. And of course, this would apply whether you're using Azure or AWS or Google Cloud or Oracle Cloud or even your on-prem data centers, right? So you can create virtual machines using this interactive interface. You can also create all sorts of resources, right? So you can create a virtual PC, which is virtual private cloud, right? Not PC for personal computer, VPC, which is their way of talking about a network in the cloud, right? So you can create networks in the cloud and then create subnets in the cloud and so on and so forth. So these are all infrastructure resources that you can create in essentially AWS, right? Same goes for Azure, same goes for GCP. And you can do that interactively using this interface. So I could do create a VPC, VPC only, VPC and subnets. You know, I could go through this visual interface and do that, right? I could also use the AWS CLI, which is the command line interface for Amazon, or the Azure CLI for Azure, and create these resources using the CLI. So when they're saying that you're writing code, instead of physically configuring hardware or interactively using tools to create things, you're not doing either of these two things. Instead, you're writing code files, right? That's like the key part here. This is like the essence of infrastructure as code. I mean, it says it in the name, right? All right, so this infrastructure managed by this process comprises both of physical equipment, so it could be actual servers, like bare metal machines, virtual machines. You could create a serverless application. It's not like a physical infrastructure, but you could create like the AWS-based Lambda serverless compute infrastructure, right? Like you can create the applications and there's infrastructure in there. You could do that with IaC. You can also create deployment packages. You can create Kubernetes clusters, you name it, right? You could do that using infrastructure as code as long as you write these machine readable definition files, right? So that's kind of like the idea here. Okay, so this definition then is inside a version control system. So this is another big one. Because you have written code, you can take advantage of version control systems. And the one that's big and popular is, of course, Git, right? So the Git protocol can be used to, in a non-central way, manage your source code, right? And collaborate with other people. So you can put stuff in Git-based systems like GitHub, GitLab, you know, Azure DevOps repos, AWS code repos, you name it, right? So you can do that and put that in the version control system, right? Then the other thing that they're talking about here is that this code is definition file is, you know, either in a script format or it's some sort of like a declarative definition, right? So rather than you, writing procedural scripts, typically in the world of Terraform, the weight is towards writing declarative definitions. We'll see that. But IaC overall could be either scripts or it could be declarative definitions, okay? All right, and then there's one last piece in this Wikipedia definition that's worth pointing out, and this is right here, is rather than maintaining code through manual processes, meaning rather than manually building your code and applying things, right? Everything is preferably declarative in nature, meaning you just declare what you want and then some system is in place to actually go ahead and create the infrastructure for you, right? So that's kind of like the idea with this, right? By the way, as I am talking, feel free to, if you have any questions, put them in the chat. I believe they'll show up as questions on my side, and I can happy to answer them at any point. Very shortly, I'm going to do a demo. So we're going to just mostly be hands-on on how this works and what this is. Okay. So yeah, feel free to. I'd love questions if you have any thoughts or questions. So the reason I'm doing this webinar is because currently we have right now two essentially two courses that I've created, and it's all related to Terraform. And I just want to talk about this really quick. It's these two, WA 3383 and 3382. So I just created this as like fresh, like we ran this a few times now already and quite successful. But the reason I'm taking you here is just to kind of give you an idea of what is entailed in working with infrastructure as code, because that's how I've lined up the course material. And then we're going to take one thing specific from here and talk about it, which is if you take a look at the objectives of this course, this is the AWS version. The Azure one is similar. Given this definition of infrastructure as code from Wikipedia, and I really like this definition, it's concise, it hits the main points. A lot of really learning how to do infrastructure as code is a few things. One is actually, of course, the skill of writing these files, right? So if we're talking about Terraform, how do you write Terraform configuration files for infrastructure as code? That's like one key skill set that you got to have, right? Then the second piece is, and this is another big one, is the approach. So a lot of times you can, I've seen teams that have actually shifted to Terraform and started using infrastructure as code, but the culture did not shift. And because the culture did not shift, they're still thinking of infrastructure in the classical sense, as if you go in and manually using physical means or using interactive tools, go ahead and modify things, right? This can cause problems because when you start using something like Terraform, it requires a change in how you look at infrastructure. And so that is key, right? So we spent 3 days like really drilling down into the mechanics of how to, set up Terraform, how to work with it, how to work with the culture shift and the paradigm shift that happens when you do things like this, right? So with that in mind, I want to actually show you one of the slides from the course. This is a good one because this whether you take the course or not doesn't matter, but it's good to know how things are laid out, right? So this is kind of like a logical / architectural diagram of what happens with Terraform, right? So as you see this screen, you might notice that there is on the left-hand side, you'll see the dev environment. And on the right-hand side, you see the infrastructure stuff, right? So the whole idea with infrastructure as code is that instead of you manually going in, so typically what happens is if you're working with AWS, right? If you're working with AWS, you manually, you manually go and directly work with AWS, kind of like that, right? You directly work with AWS using the console or the CLI. Your colleague might directly work with Azure in the same way, right? So we're not doing that anymore, right? The paradigm shift here is that instead of doing this, you're going through this very interesting process where you write code, these files that you see, main, compute, network, storage, variables.tf. These are all Terraform configuration files. You write code here and you apply it so that the Terraform core along with something called providers, which are extensions, actually does the infrastructure provisioning for you. Yeah, so that's kind of like the idea here is you are using code to then make infrastructure happen. And you're doing this in a declarative fashion. And you will see what that means in just a little bit when we do the demo. Okay, so you have code on the left-hand side. You're writing some code, and you're doing this in the declarative sense where you go in and say, this is what I want. I want one VPC, and I want one S3 storage bucket, and I want a virtual machine in EC2 instance. And you just list out the things you want using a very specific syntax, using the HashiCorp config language, and then Terraform does the rest, right? And when you start doing it this way, like when you start applying things this way, you can automate this entire process. And that's also, that's one of the big advantages of using infrastructure as code, okay? So as you're doing this, something to keep in mind is all infrastructure changes, whether you're creating brand new infrastructure, updating existing stuff, removing things that are not needed. In this paradigm, everything happens using this process, using this workflow from left to right. You did not at any point go in and make these changes from the right-hand side. It would be very tempting. So one of the major failure points in organizations that take Terraform is they'll set up things using Terraform, but then someone's going to go in and update something directly in the console, AWS console or the Azure portal, right? Or using the CLI. So they've done something outside of Terraform, and that doesn't really work and doesn't pan out well, right? So this requires a culture shift. And if you can do it, you reap benefits because you get a ton of benefits from using infrastructure as code, especially Terraform this way, which is consistency in how things happen. You don't, all the changes and all the things you're doing, they are all tracked out because everything is in code and everything's in Git, right? Or some source code management. It doesn't have to be Git, but let's say Git, right? Everything's in source code management. And that, that then allows for people to see what has happened, what code led to this infrastructure and make changes, roll back, go back in time if necessary, debug problems in ways that was not possible, in the past when you were just directly applying changes. Yeah. So with that in mind, what I want to do is we're going to take a look at like a very basic example of how to do Terraform and what types of resources you could potentially create, right? And this is like one of the, this kind of relates to one of the hands-on exercises you do in my 3-day class. The 3-day course that I teach for Amazon and for Azure equivalents, they're similar, as I said, but it's mostly just a lot of hands-on exercises and practical discussions, like the one we're having right now here, like the stuff I'm talking about. So the demo I'm going to do is just like a snippet of one of the demos / labs hands-on exercises that we do inside the course. But given that we have just a limited time, I'm gonna do like an abbreviated demo to kind of show you what's possible, right? And hopefully you leave this webinar with a takeaway around this, which is like, yes, you can do IaC, and you can seriously consider what's needed for it, right? To actually shift to using IaC. All right, so enough talk here around this slide. Let's go ahead and switch over. So I have a virtual machine here, and what I'm going to do is I am going to create a brand new, so I'll start from scratch. So this is going to be like from scratch, kind of like a demo. And again, any questions, please ask them in the questions box or the chat box, and I think it'll just prompt me on what that is, and then I can answer that. So what I'll do is, hopefully you guys can see this. Here, I'll make this a little bigger. There you go. So, all right. So what I'll do is I'll just start. This is a Linux-based virtual machine. It's Ubuntu. This is actually one of the virtual machines we'll use if you do hands-on exercises in the course, right? And so you get to actually try a ton of this stuff out, which is a lot of fun. But what I'll do is I'll just start with a webinar demo. So I'll just create a new folder, webinar demo, and I'll just go to webinar demo. And for the rest of this session, this webinar demo folder that you see right here is going to be my project folder. And my intention with this is to, at the very least, create some sort of like a virtual PC or, and maybe some other local resources right here in this example. Okay, so one of the things I can do is in this webinar demo is, first of all, create a Terraform config file. And this will be in line with this picture that you saw in just a moment ago, which was, config files. So what I'm doing right now in my demo is I'm going to set up this side of this equation. Yep. And after that, what I need to do is download the provider, which is like a plugin. We go into like details. We spend like almost half a day on providers, but essentially Terraform by itself is just the orchestrator of infrastructure provisioning. What really does the job is these extensions or plugins that you download in addition to Terraform. So to spin up anything in AWS, you'll need the AWS provider. For Azure, you need the Azure provider, and so on and so forth. Yeah. So I will be using the AWS provider for this. Okay. So what I'm interested in is I'm going to go ahead and create a new Terraform file. So I'll add a new file in this webinar demo, and I'll just call this hello.tf, hello world.tf. Okay. So this is going to be the file I'm going to use, and my intention is in US West 2 region of AWS Cloud. I'll go into VPCs here. So this is the list of all the VPCs. You can kind of see that there is one VPC. This is like the default VPC that's already there. Okay, so I'll just let that be. But my intention is to create another one here, but I don't want to do it using this interface. I want to do it using Terraform. So one thing you should know, in this machine for this lab, I've already set up my machine to work against Terraform. I have the AWS CLI installed on this machine. I have Terraform configured. I have the authentication piece configured. Those are all things that we look at in the course in one of the first exercises where you configure all that, so you learn all that. But for the purposes of this webinar, we're not going to go into those details. We're going to look at how Terraform works. So all of that is set up, just so you know. I did a little bit of prep work to do that. Okay, so in hello.tf, my intention is to, so the goal is to create a VPC, or virtual private cloud, right? This is like a virtual network. This is what you would call a virtual network in Azure, right? And so for this, I'm going to use what's called a resource block. And because I have used VS Code, I've already installed the Terraform extension in Visual Studio Code. It's giving me all of the help, nice little help, autocomplete and all of that. If you don't, the code is still very simple. This is called HashiCorp config language. That's what I'm using. The resource type I'm going to use is AWS_VPC. Okay. And the name for this code block, I'm going to just call this the hello VPC. This is not the name of the VPC itself in the cloud. This is just the name of this code block here. And in here, basically, I'm declaring and to Terraform that I want a VPC with the following properties. Yeah. So here are the properties I am interested in. Okay. So 1 second. Let's see. All right. Just getting used to GoToWebinar. I was making sure you guys can see my screen. Okay, cool. So this is a code block where I'm writing code to create a virtual private cloud, right? So in a lot of Terraform code, what you do is you create a resource block, which is, hey, Terraform, I need a resource of this type, and here are the properties. So the only property I'm going to put in here is cider_block, like that. And I'll just put in a cider block for IPs here. So 10.0.0.0/16. So I'm going to use this as the cider block. Just remember, if you don't know what these are, we're just configuring a network in the cloud, so you need this parameter. You don't necessarily need this, but for my demos, I'm using this. You could have created other types of resources, and they would have a very different set of parameters here, right? Or arguments that you're going to put in. It really depends on what kind of infrastructure you're putting up, right? So how do I know that this is a thing? Well, what I can do is I can just go to registry.terraform.io. This is the Terraform public registry. And if I browse providers, I can look at the AWS provider, go to its documentation, and then if I scroll it, so I've done this, you can tell I've already done this, but this is how you would typically do this is, can I dismiss this? No, okay, it won't let me dismiss that little bar. So I'm gonna go to the bottom here under VPC. And if I scroll down in here, I can see there is, at some point, there's a AWS VPC's resource type. And so that's what I am actually interested in. There it is. That was a data source. Oh man, why is it so difficult to scroll in here? Okay, give me 1 second. You know what I can do is right here on my local machine. Registry.terraform.io, browse providers, AWS, documentation, scrolling down to VPCs, and under resources is AWS VPC. So there's an example literally right here on HashiCorp's Terraform registry website on how to create a virtual private cloud using HCL, right? So I could just literally copy paste that, right? That's kind of what I'm doing. But if I scroll down on this page, I'll see all of the arguments I could potentially specify. Even cider block is kind of optional, but you have to look at any resource and you'll see that there's thousands of different types of resources under various categories that you can create just for Amazon, right? It's kind of ridiculous how elaborate this is, right? So what I'm going to do is I'm going to go back in here and look at this code. This is the code I'm going to be using, right? Now, I'm also interested in just giving it some metadata. So I'll do this. So on day 2 of this course, we actually do a deep dive on basically a ton of different types of resources on HCL, which is the language itself. We also take a look at a few other things like state and modules and everything else, and we do like a deep dive and understand how those things work. Here, what I'm interested in is also telling Terraform about my preferences around how Terraform should run and what version of Terraform do I want and which version of the provider I want. So I'll create a Terraform block for this. And in this Terraform block, I'll specify that the required version of the Terraform CLI, which is basically the Terraform command line interface that I'm going to use in just a second, the required version is, if I say Terraform version, let's see which version I have got, version 162, right? So I'm just going to specify that the version needs to be greater than tilde greater than 1.6, which is basically, this is the pessimistic operator that says, hey, any version 1.x is fine as long as it's above or equal to 1.6. So 1.7 is fine, 1.8.2 is fine. What's not cool is something less than this or something 2.0 or above, right? So I'm constraining which version this will work with. Here it's cool. Down the road, when this is running in an automation, in a CI/CD pipeline, in a GitOps pipeline, this will become more relevant. The other thing I'm going to do here is required providers, and I will specify that the AWS provider I'm interested in also needs to be of a very specific version, HashiCorp/AWS. This is the source, this is the AWS provider, and the version I'm interested in is anything in the 5x range, right? So this is the pessimistic condition operator for 5.0, which basically says anything in the 5, this could be any number higher, 5's got to stay 5, right? So it can't go 6.0. Okay, so we spent some time on version constraints, like there's a whole section on that. You actually do a lab around version pinning, a ton of best practices. Anyway, so we've done that, but the main key star of the show here is this resource, right? All right, my project is ready to roll. The one thing I'm going to do in here is, if you're probably aware, if you've done AWS or Azure or most cloud providers, give you the ability to create tags for your resources. I also want to make sure that this has a tag in it. So I'll say tags equals, and then in this little collection, I'll say the name tag needs to be, let's say, hello world VPC, something like that, right? Or maybe I'll just make it one word, no with dashes, hello world VPC, right? So I'll save that. That's the name tag, right? My code is ready to roll. Let's see how we take it through the process here. So my code is ready to roll. I could at this point put it in Git. What I'm going to do is I'm going to take it through the command line interface tool, the Terraform command line interface workflow, which is something we also take a look at in details. So by the way, you might notice that I'm talking about some of these topics, and you potentially can, and yes, you're right, drill in there and then spend like an hour or two on each of these things that I'm talking about. That's what we do in that class, right? So this is just the overall workflow to get this going, but in the class we go and dig in deeper per item, just FYI. All right, so what do we do now? We have the source code. We got to take it through its paces. We're going to run the Terraform workflow here. So I'm in that directory, labs webinar-demo, which is where my hello.tf file is. Just verify it is there. So the first thing I'm going to do is initialize this as a Terraform project, Terraform init, initializing the backend, which basically downloads. I don't know if you noticed just now, suddenly there's a .terraform subfolder inside webinar demo, and if I expand this, it has the provider, the AWS provider, the binary bits for that provider downloaded. That's the thing that's going to interface with AWS on my behalf in just a second. Right now, we're ready to roll. I'm going to go through just the basic Terraform workflow here, which is init to initialize this project. The next thing that you typically do which I like to do, and this is what I tell my students to do, is always validate your code all the time whenever possible. And Terraform validate can do that, do at least basic syntactical checks. It won't necessarily verify if your infrastructure will provision correctly. For that, you'll have to actually provision and find out. But at least you can validate you don't have some silly mistakes, syntactical mistakes or other things. So Terraform validate. Okay, cool, success. Looks like the configuration is valid. Then the next thing I'm going to do is, let me actually just expand this a little so we can see my terminal a little better, more space. So next part of the workflow is typically coming up with a game plan. And when I say coming up with a game plan on what I mean is, because this is declarative, this code is declarative, and what I mean by that is this is declarative code. I haven't told Terraform how to create this. I've just said I want a VPC with this CIDR block and this tag. I'm not telling it how to do this or how to go about creating it. Just go ahead and make this happen is all I've asked it. So, right, so that's declarative code. So whenever you have a declarative code, very likely the CLI or whatever tool you're using that will understand your code and make things happen, the first thing it has to do is come up with a plan on how it's going to execute and run that, right? If anyone here has played with SQL Server in the past, or any kind of like a SQL-based tool for databases, SQL, you know that SQL is a declarative language, right? You're just declaring what you want as a result from a query. But then the first thing that they do behind the scenes, if you really look under the covers, is that the engine will come up with a plan, right? Like a SQL plan, right? So if any database admins in here, you've probably heard of SQL plans. Like, it comes up with like, this is how I'm going to go ahead and query these tables to get the data, right? That is typically a telltale sign that the language you wrote things in is declarative in nature, right? Because there's no plan in there, it's just what you want. Similarly, with Terraform, it does something along those lines. In fact, in Terraform, you can explicitly ask it to come up with a plan, which is, I could say Terraform plan. And you'll notice what it did was it came up with a game plan on what needs to happen to actually make this desired configuration that I've got a reality, right? So it is descriptive, it's in its own way, but it's obviously very different from like a SQL Server plan. That's a whole different paradigm, right? But it has some sort of a plan where it says, okay, we're going to create a VPC, and it will have all of these properties, which I haven't specified, but they're there because a VPC will have those properties anyway. And we'll know after the apply phase, which is coming up next, what the values will be. Right now, this VPC doesn't exist, but once it's out there, we'll know its unique identifier, which would be its ARN, right? The Amazon resource name, right? Azure has something similar on the other side, right? Each resource has its own ID and everything else. And so going with that, moving down, it also says it's going to create a tag in there too. Awesome. Okay. So if you're doing this in an automation pipeline, a CI/CD pipeline, like in Jenkins or GitHub Actions or anything else, you typically actually save this out as a plan file and then apply this plan. We're doing this as a demo right now in person interactively, so obviously I'm not doing that right now, but that's what a plan file looks like. The next part of the workflow would be an apply. So Terraform apply, which, by the way, when you run it, also runs the plan phase, that's why if you ever do this interactively like I am on a developer machine, you don't have to do a Terraform plan. Just a quick tip, because the apply does the plan anyway. It'll show you the same plan, about the same, and then it'll ask you if you want to make this a reality. So you could just say yes or no here, right? So if you do a plan and you don't save it and then you apply, you're just adding an extra step that you didn't really need in an interactive workflow like we are here. In automation, you would have plan actually run, save the file, and then apply will take the input of the plan and run that. So I'll say yes here, which is basically, do you want Terraform to perform these actions? I'll say yes. Okay, so in about like a couple of seconds, it went ahead and says, it claims it has created a virtual PC, and its ID is 0D, 0D something, ends with 2DE, right? So let me go into my list of VPCs and see that if that really happened, right? So I'm gonna go here. Okay, there's Hello World VPC. If I click on this, I can see that it is there. Awesome. If I go into the tags section, I do see a name tag with Hello World VPC in there. So interesting, right? Okay, question for you now. Just a rhetorical question because you can't talk to me in a webinar format. But the thing to keep in mind here is this is the infrastructure. There's nothing else to it. It's the way to treat this code is that this code is the infrastructure. If you treat it as like a normal script that does infrastructure, that's not what this is. And what I mean by that is, let me copy this. Okay. And I'll create another VPC. Okay. And I'll call this goodbye VPC. So a second VPC, right? So notice my code. I've got two VPCs, hello world and goodbye, two different VPCs, right? How do I now make this run? So on day one of this class, I spent so much time on talking about the Terraform declarative infrastructure code being idempotent. You might have heard of that phrase. It basically means that its only job is not to run this as a bash script, but just to take this and make sure that the reality matches whatever you have desired. So right now, the reality is that there is something called a hello VPC. What isn't there is a goodbye VPC, right? So if I run Terraform apply again, let me validate first, make sure that I didn't make a silly mistake. Okay, now I can do a Terraform apply. Comes up with a plan, and notice what the plan says. It says 1 to add, 0 to change, 0 to destroy, which means, okay, your desired configuration has one extra resource than what the reality is. So I'm going to add this one resource, and that's what the 1 to add is here, right? So if I say yes, looks like I now have a second VPC. Let's verify that. Right, so your VPCs, refresh. Right, so you see that second VPC with the F9F, 3F9F, last 4, that's the second one, right? So this is very interesting, right? Let me show you something else that's interesting, which is how do I delete hello VPC from here, right? So think about this for a second. So I have a sip of my coffee. My goal now is to remove hello world VPC from this mix, right? How do you do this? With declarative code. Now, this is where this is one of the key things that requires a culture change. And trust me, you can spend 5 days discussing the implications of this in an organization. So just touching the tip of the surface here. The way you would do this is not by calling a script that deletes things. You just literally remove this thing from the code, because remember, this code represents the infrastructure, right? So if I'll just comment this out. So that's about the same as deleting it, right? So it's gone, right? So now when I do a Terraform apply, first the plan part runs, and you'll notice what happens is it looks at your code and says, oh wait, the actual infrastructure out there has one extra item than what you have here, right? And it's using the state file to figure out that this is the infrastructure you created, not something that somebody else created and it's not here, right? So it keeps track of that. But notice it says, okay, hello VPC was removed from here, so I'm gonna actually remove it from the actual infrastructure out there, right? So hello VPC will be destroyed, right? So if I go ahead and say yes and confirm this change, okay, that destruction is complete. Going back to Chrome here, I'll go ahead and refresh this list and you'll notice that hello VPC is gone, right? I could similarly delete this, right? So I could just comment this out and then do a Terraform apply. And then you'll notice that it'll remove this one as well. So another one to destroy, say yes. If I go back to Chrome and refresh, that is gone too. Kind of get the idea, right? So you'll see how this is kind of like tying in the thread with infrastructure as code is literally, this code is the infrastructure, right? So if I could like give you one thing to remember, this is not your usual run-of-the-mill bash script, right? It's idempotent infrastructure as code, which means right now, those two things are gone. If I run Terraform apply again without changing anything, you'll notice it says, oh, nothing has changed. Your real infrastructure matches your config. You're good to go, right? And I can just as easily bring these back up again, right? So I can uncomment that, save it, Terraform apply, and you'll notice that, and then I'll say yes to add, you notice that, right? Say yes, and then it's creating those two things. I go back in here, you'll see both those items are there, right? So very interesting. So then one last thing I want to show you is if I run Terraform apply again, because it's idempotent, which means that it shouldn't, you know, the final state should be still the same as it is right now. You'll notice what it does. Oh, your infrastructure matches your configuration, so you're good to go. So no changes are needed, right? You see that? This is very different from a bash script with AWS CLI stuff in it, like, or Azure CLI command. If you run that script 4 times to create a machine, it might create 4 different machines, right? It doesn't do that here, right? You can run this apply like 50 times or 1,000,000 times. You're not going to get another VPC. And if you remove something and apply, it disappears from there, right? There's one last piece of the workflow, which I should just mention for the sake of completion, which is Terraform destroy. Typically in real life, when you're working with Terraform workflows, you won't run destroy, because destroy will basically delete the entire infrastructure that this project created. So very likely you're not going to do that. You're probably removing certain resources. You can comment them out, remove them. But here, just because I want to end this demo in just a moment, I'm going to destroy everything. And just to show you that this is like the last piece, it deletes everything, right? So, and just it's gone. So if I go back into here and refresh, you'll see that those 2 VPCs I created from here are gone, right? So fascinating, right? So what we did was we went over this workflow and created infrastructure in Amazon Cloud, right? Super fascinating. So this right here, as I mentioned, you can spend a lot of time on each of these items to really understand what's going on to bring it into your organization. There's also this state file. The state file is Terraform's bag of tricks in some ways in how they maintain and keep track of what has been created through your project. You know, so they have a local JSON-based file that keeps track of that can be either in your project folder or it could be remote in a remote location. And that's something for perhaps another webinar. So to recap, going back to the IaC definition we're talking about, what we just saw in this demo was I created a machine readable definition file, the TF file called hello.tf, right? And I used that instead of physical hardware or interactive tools, right? I just used that to deploy infrastructure, right? And you saw, because it's in a folder, it's a project, I could just as easily enable Git on it and use version control, right? We also saw that the code was declarative, right? So Terraform came up with a plan on how to create those resources, right? And then it went ahead and carried those plans. All right, so in summary, I would say that as infrastructure gets more and more complex and everything is digital now, you'll see that the traditional way of doing things, which is interactive interfacing with any of these infrastructure platforms, cloud providers, while you can do that point in time and it works great, and it's good to know how to do that, at scale, this is not going to pan out, right? Like typically at scale, and by scale I mean you're provisioning thousands of virtual networks or hundreds of virtual machines, and you need to provision the same kind of infrastructure for various application delivery teams. And you want to be able to maintain that. One infrastructure team might not be able to do that. So the work has shifted now into creating code that can do that. So in this paradigm, at least, you shift from doing things directly right here, right, to becoming this person here that writes code and tests it out to make sure that the infrastructure that's created with this code is legit. And then depending on how your org is set up, you would use that to actually build your infrastructure, right? And so the paradigm shift is in that, right? And so hopefully you got to see a little bit of that with my example that I just showed you with the VPC. So with that, I thank you so much for your time and your attention. If you have any questions, please put them in the questions box. If you have any thoughts you want to, just mention. And I will just say, please, 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 if you're really interested in this, sign up for the class. We have both the AWS and the Azure version of this course that really deep dives into the world of IaC and Terraform. All right, so I'll just hang here for just a few moments to see if there are any questions. Otherwise, we're gonna call it. So, not sure. I see Anne, you're still there. I'm just gonna probably stop the screen showing. Let's see. Yep. So if there are any questions, please put them in the questions/chat box. So I'll hang here for a couple of minutes because sometimes it takes a moment for the questions to come through, and then we'll take it from there. Matthew, thank you. Great intro into Terraform. Thank you, Matthew or Matt. Really appreciate it. Hope you found it useful. And yeah, hope to see you in one of the classes. I believe there's an eval for this that if you guys have the ability to, perhaps you can, here, I'll put this in the chat box. So if you're still here, and if you have a moment and you can just do a quick eval of this webinar, that would be appreciated too. All right. Thank you so much for your time, everyone. I hope you have a great Thursday, and I'm gonna see you hopefully in one of these Terraform classes down the road. Take care. Have a good one. Bye.